Today is the 16th of May 2024. Okay, and this will be our second probability revision video. Okay, I've already, as I said, done some probability with you earlier on. So if you're a foundation student, that is about enough for you. Okay, but if you are not and you are a higher student, then maybe I might have to explain a bit more stuff. So, as I said yesterday, instead of coming up and saying probability in true, which I think I already have, I just said revision, okay, because I'm just adding a bit of stuff. So, yesterday, everything we've learned in probability from the earlier video, I tried to recap that, brought in some questions, and then we look at the all law where you add. Okay, now today I'm going to show you another aspect of we did relative frequency. We went on to look at the all law. Okay, so today I'm going to show you another aspect, so I'll just be introducing you to a little bit of aspect, and then for the higher student, and explain it and do examples with you in case you get any of these questions. Okay. Now, thank you to all my subscribers. Thank you so much. um if you haven't subscribed, please, if you can, please do. And if the account is not yours, ask permission from the account holder. Okay, you can follow us, you can share, you can subscribe, uh, like it, give us nice comment. As long as it's not going to cost you anything, please do support the platform. Okay. um Also, um or you can also ask somebody to help you open your own account. That is your own account, so you can watch it anytime you can, or you can use it to share it out. Okay. On the comment section, you always see follow my notes slash script. Okay, assuming today is your first day you are watching the video, follow the notes, please. It's not like a film you've watched before that you can watch the abstract. So, for instance, this is root of 9. Okay, so if you hear 9, it's the square root of 9. Don't ignore the square root. So that's why you should follow the notes. Beware of scammers, please. Please beware. Okay, I've been sounding this warning. Don't send me a note and say I donated to this. It's not coming, it's from me. If I want you to help me donate to a charity, I will let you know. Okay, if you've not heard it from me. Okay, now by now you know how I sound. Okay, so if you've not heard it from me, please, just use the platform, be happy, and get on with your life. Get what you need to do. Okay. Recap. Please, I've already recapped. Okay, watch last video for recap. We did relative frequency. We look at mutually exclusive events. I explained them and I've explained them before. I don't want to take much more time, so please follow the note. Now, again, I'll start. I think this week and next week, I'll devote it to mental maths so that it could help you think faster, because we are getting into that stress period. Okay, so I'll just devote it to mental maths. Okay, Now, this are said, so all is square root, but you need a good knowledge of your timetable. And we are going to use board math. Because of the bracket sign, we will do the bracket and then do that. So this can be written as this, okay? So square root of 2 times square root of 9 divided by square root of 9. The square root of 9 will cancel out. So your answer will be square root of 2. 2. Square root of 3 times square root of 14. All divided by square root of 3. Okay. So now the numerator will be square root of 3 times square root of 14 divided by square root of 3. So we'll cancel out um, the square root of 3's. So we have square root of 14. Okay, if we break it down to 8 times as 7 times 2, it will be square root of 2 square root of 7. But we want to simplify, so this is the simplified form that we can leave it. 3. Square root of 6 times square root of 5, all divided by square root of 30. The numerator square root of 6 times square root of 5 is the square root of 30, and the denominator is the square root of 30. We can cancel out, so our answer is 1. 4. Square root of 6 times square root of 6. We know that is 6, okay? 7. 5. Square root of 7 divided by square root of 7 is 1. Okay, that is 1. Okay, assuming it's times, then it's 7. But we are dividing, so this root of 7, the root of 7 will cancel out. So we are left with 1. Okay, 6. We have more here. Square root of 7 times square root of 7, which we just did, divided by 7. So the 7 will cancel out. Okay, we don't want the square root to be in the denominator, otherwise we have to rationalize. Okay, so it will be square root of 7. Square root of 52 will give us square root of 2 times square root of 26. Okay, 26 is the same as 2 times 13. So we now have square root of 2, square root of 2 times square root of 13. Square root of 2 times square root of 2 is 2 root 13. So that will be our answer. Okay. 8. Square root of 18 is square root of 3 times square root of 6 times square root of 3. Now 6 is 2 times 3. So we have square root of 2 times square root of 3 times square root of 3. Square root of 3 times square root of 3 is 3. So 3 root 2. Okay. This, you can do it if you have a knowledge of times table. But if you don't have a knowledge of times table, as I'm talking you through, you are seeing my thinking pattern. Okay, so that's why I don't believe in guest putting PowerPoints. Okay, so now that you are seeing my thought pattern, how I arrive at this answer, when you also see, if you watch my video little by little, when you see it, you'll be able to say that, oh, okay, this is what I saw, and then you also do that. You cannot go wrong. Okay, now today we are looking at the second part of probability. I don't know how many videos I might do on this, the revision, but we will see, okay? Because it's a bit complicated. I've explained a lot to you, so it makes my work here easier. Okay, now let's look at the independent law, the end law. Okay, the last time we talk about the all law, where we add. Okay, now today we are looking at and so the probability of an event A and an event B happening. Okay, so in this case, immediately you see end, you have to times both probability. And in this case, the likelihood of the probability happening becomes very small. Okay. Using the end law, multiply the individual probability. This decreases the likelihood of the combined event happening. Okay, so it becomes a combined event. I will explain it to you. Okay, example, it will be very difficult for two ones to occur at the same time than a one in a dice throw. So, for instance, if you throw a die or dice, okay, if you throw one die, you can get one, two, three, four, five, six. The probability there is 1 over 6. Okay, the probability of getting a 1 is 1 over 6. If you have two dice, the probability of getting 1 and a 1 becomes very difficult. A 2 and a 2, a 6, because you are throwing it at the same time. Okay, there is a chance that you get a 2 and a 3, but the probability of getting two sixes at the same time, okay, this is where the end law come in. So for instance, if I throw one die, if I throw the dice like that, and the probability of getting a one is 1 over 6. Okay, but assuming I throw in two dice and I want a 1 and 1, okay, I want 1 and 1. So that is the word you are looking for, 1 and 1. That one here, this word here, and. Okay, so if you are looking for that, then it becomes 1 over 6 times 1 over 6, which makes it 1 over 36. So the probability of getting two ones happening at the same time reduces drastically. Unlike it's easier to just get one. Okay, if you throw one die, you can get a one, or you can get a two. You can, but if you have two dice and you have to get a one and a one to win, then it's difficult. For instance, if there is a game, then that is the probability, and it's very very small, 1 over 36. Okay, so this is where we use the end law, and the end law means you multiply. You remember when at the beginning I said the all law and the end law, and I said I would bring the end law because we talk more about the all law, okay, about mutually exclusive events. But here, so I'm going to go through some examples with you today, and then we'll end it there, and then tomorrow we'll continue with that, and then we'll do more stuff, okay? So, for instance, picking two red dresses, we've already seen the loss probability box. Okay, it's easier to pick one red dress if I want one red dress, but if I want two red dresses at the same time, the probability of getting that is difficult. Okay, because they've mixed all the clothes. I'm not looking. I just dip in my hands, and they said pick two out, and the chances of it should be two shares. So two red dress or two um, green dresses of four two blue dresses. Okay, so now in a box, okay, you have four red dresses, four green dresses, and four blue dresses. So the probability of picking one red dress is 4 out of 12. Okay, because the total is 12 dresses in the box, and you have red dresses. So the same way, the probability of picking a green is 4 out of 12. Of picking a blue is 4 out of 12. Okay, knowing that, which is 1/3. Okay, now knowing that, okay, so now picking two red dresses. Okay, so you are picking two red dresses, red and a red. Okay, so here you are not just picking one, you are picking two at the same time. So now it's 4 over 12 times 4 over 12. And when you simplify, it simplifies 1 over 9. Like um, we said, is 1/3. So 1/3 is times another 1/3. Okay, so it will be 1 over 9. So if you have 4 over 144, you can reduce it to 1 over 9. Again, the likelihood of this same thing, the two red dresses happening, reduces the probability. Because if you just wanted a one red dress, or one green dress, or one blue dress, there's a chance that you can get that, which is 1/3. But you want to pick two at the same time. So the chances of you getting two red or two green or two blue becomes very, 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 very difficult. Okay. Now, picking two green dresses. So you either pick green and green at the same time. Okay. You are not picking it one and going back. You are picking it two dresses. You've been asked to pick two green dresses and you are not looking. Okay. So again, that will also be 1 over 3 or 4 over 12 times 4 over 12. And if you simplify, you get 1 over 9. Again, the probability of making two blue dresses, 4 over 12, okay, times 4 over 12. This is not plus, that is 4, please. That is 4. It looks like a plus, which is, if you simplify, you get 1 over 9. So this is what I'm trying to say to you. Immediately the end log comes in, it's speaking two things at the same time. So like the throw of the die, two dice, you need two and a two. Okay, so immediately you see the two, then it means that it's a bit difficult to get the box two red dresses. You have to pick it at the same time. Okay, so your hand, you have dip your hand in the box. You don't look in the box. You just pull it out. Assuming you work in a shop. Okay, it can happen, but the probability becomes small. Okay, maybe you work in a retail shop. Okay, now again, assuming you have some fruits in a box, 5 oranges, 5 apples, 5 plums, okay, in the box, okay, you are not allowed to look, okay, maybe it just came from the farm. If you want one orange, it will be 5 out of 15, okay, because there are 5 oranges and a total of 15. oranges, apple, and plum in the box. So it will be 5 out of 50, which will be reduced to 1/3. Okay. But assuming one apple is 1/3 again, because 5 out of 15, 1/3. One plum is another 1/3. Okay. But assuming they ask you, this time don't pick two. Okay. You have all the 15 there. Okay. And they've been mixed up. Pick two oranges. Dip your hand, grab two oranges, take out. You are not looking, you are not feeling. Okay. Um, it is difficult. So you want to pick two oranges. So that's why it comes and one orange, another an orange. So that's where the end law come in. So it's 1/3 times 1/3, which is 1/9. Okay. Two apples. 1/3 again times 1/3, which is 1/9. Two plums. 1/3, 1/3, which is 1/9. So what I'm trying to show you is, um, if you have, so what I'm trying to show you is, if you have to pick one, the probability of getting that one is easier than the probability of getting two. So immediately you see this kind of questions that you are picking at the same time, then you have to start thinking of the end law. Okay, so that is where you multiply, and your end law you have to multiply. So the probability of a raised to it and a raised to it. So you the first probability of the raised to it, because they are not going to replace, so you multiply the two probabilities together. The probability of getting um, two ones, 1/6, okay, in the throw of a die. So you multiply. So if you throw two dice at the same time, the probability of getting two threes is 1/6 times 1/6, which will be 1/36. Okay, the probability of getting uh, choosing let's see um, two beads of the same color, okay, at the same time, two yellow beads in a box. So if you know the probability of picking one bead, then you have to multiply both. Okay, so this is where the end law come in. Thank you so much, okay, for to all my subscribers, those who have subscribed. Thank you so much for sticking with me. I appreciate you a lot. Um, please subscribe, like, share, okay. Help us circulate the platform, okay. Follow my notes/script. It's very important today, okay. I hope you are enjoying the mental math, okay, and I hope it's helping you think a bit more faster, especially the use of your timetable. Beware of scammers, okay. Thank you very much for joining me in today's video, and I'll see you in the next.